Okay, today's lesson is going to be kind of the intro to this chapter. It's going to be talking about three-dimensional figures and then also cross-sections. Again, with these three-dimensional figures, we can call them polyhedron. It's going to be a 3D figure, and the surfaces are all going to be polygons. So we'll have prisms and that are made of rectangles, squares, triangles, and stuff like that. Three things that we'll have are faces, edges, and vertices. So with faces, it's going to be the surface. That's going to be our two-dimensional shapes. Each face is going to be a two-dimensional shape. The edges will always be line segments. And then vertices will always be a point where I have edges meeting at. It kind of goes back to what we did in the very first part of geometry, learning about line segments, points, planes, and stuff like that. So over here with this this pyramid that we have, if I wanted to name a face, I could take this face right here, this triangle, and one of the faces is going to be triangle HEF. If I wanted to name an edge, I could just take one line segment, so I can just do segment HE. And if I wanted to name a vertex, again, I could just name any point that I wanted to here. So how about I choose the bottom, I choose point E right there. So vertex would be just a point E. One of the things that we have with all polyhedron is we have, this is Euler's formula, which is that for every 3D shape, my faces and plus my vertices will always equal my edges plus 2. So if I wanted to kind of figure out how many faces this thing has, I could use that formula to kind of work backwards. So faces plus vertices equals edges plus 2. So for this one, I don't know how many faces I have. I have 20 vertices. I have 30 edges plus 2. And so I can just kind of work my way backwards, subtract this 20 to the other side, and get that this thing is going to have 12 faces. Same thing over here. If I can identify, so this thing has, if I want to count the faces, I've got a top and a bottom. I've got 3 rectangles on the front, and then I've got 3 rectangles on the back. So I've got 8 total faces. I can count my vertices by just counting each of the points here. So I've got 1, 2, 3, 4, 5, 6 vertices on the top, and 1, 2, 3, 4, 5, 6 vertices on the bottom. So in total I have 12 vertices. And so again, sometimes it's kind of a pain to count all the edges, but if I wanted to figure out how many edges I had, I could just go ahead and use Euler's formula. I can go faces, so I've got 8 faces plus 12 vertices equals my edges plus 2, and then work my way backwards. 8 plus 12 gives me 20, and then subtract 2, so I have 18 edges. And if I wanted to, I could go ahead and count all the edges. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 edges there. This part can be a little tricky because we have to kind of imagine three-dimensional shapes. So when I'm drawing cross-sections, I'm kind of thinking about taking a knife and kind of cutting into an object. So for this first one right here, this yellow piece of paper is kind of like, think of it as like a butcher's knife, and I'm cutting into some sort of like a piece of cake laying on its side or something like that. And so a cross-section is just trying to figure out when I cut into that, and then when I look into the shape, what kind of shape is that going to make? And here you can kind of tell when I cut into that I'm going to have a shape that looks like the face that is parallel to it. So since I'm cutting vertically into this, it's going to reflect the face of my three-dimensional object that is parallel with that. So when I cut into this thing's vertical cross-section is going to look like a triangle. Same thing with this second one. Again, I can imagine that this is my my butcher's knife. I'm cutting horizontally into this thing, and so my horizontal cross-section, again, think about if I were to cut into a can of pop, and I'm going to slice it, and then I'm going to look directly above it, and I'm going to look at what is made. If I'm looking directly at a cylinder, if I stand it up, it's just going to end up looking like a rectangle because I can't see the rounded edges. So horizontal cross-section is going to be a rectangle. It'd be just like I'm cutting a pop can in half, and then I'm looking at the pop can. And then this last one, I want to do a vertical and a horizontal cross-section. So with my vertical cross-section, again, I'm pretending that I'm taking a butcher's knife. We're really good at drawing. And I'm slicing it from the top, slicing it vertically. And so when I slice it vertically and then I look at it, again, if I'm looking at this thing directly, looking right at that face, what I'm going to see is I'm going to see something looking like a trapezoid. Because again, I can't see the top of it, I'm going to slice it and then I'm going to look directly into it. And then if I want to do a horizontal cross-section, what I'm going to do is I'm going to take my knife, and I'm going to cut it horizontally. And so I'm going to slice it across like that, and then I'm going to look at it from the top down. So I'm going to slice it horizontally, and then I'm going to look at it from directly above it. Again, it's going to look like the plane that is, or the face of the object that is parallel to. So if I slice it horizontally, I'm going to look up at the top, from the top, and it's going to look like a circle. On the back of your notes then, again, just two more that we're going to go through here. So this first one, again, my vertical cross-section. I'm going to take a knife and I'm going to cut it vertically. So I have my knife here, and I'm cutting it vertically on the top. And then I'm going to look at it, I'm going to look at it from, directly on, so it's going to look like the faces that it's parallel to, and so it's just going to end up looking like a big rectangle. Those would be the pieces of my hexagon. But again, I don't even need to really put those on my cross section because when I'm looking at it, I'm not going to be able to see the dimensions coming out at me. It's just going to look like a rectangle. And then same thing when I do my horizontal cross section. I'm going to take my knife and I'm going to cut it horizontally, and so it's going to slice it across. Oops. And then I'm going to look at it from above, and again it's going to look like the plane that it's parallel to. And so the plane that it's parallel to is going to look like a hexagon. And then the last one here, oops, again, a vertical cross section means that I'm taking my knife and I'm slicing it down. And then I'm going to look at this thing straight at one of the faces, and so it's going to end up looking like a triangle. And then a horizontal cross section, again, same type of thing. I'm going to actually cut this thing from the side. So I'm slicing this thing across, and then I'm going to look directly above it. It'll look like the plane that it is parallel to, which ends up looking like a square, just like the bottom of it.